So right now we're just going to set it up, and we're going to do the first one with our regular calculators, and then we'll see who wants to bother with the graphing calculator. Cool? Because you still got to do the math before you can punch anything into your graphing calculator, right? You got to set it up. So let's set this up. So my man wants to make a garden. He's got 100 meters of fence. He would like to enclose the maximum amount of area with his fencing, right? He's got 100 meters only. So let's sort this out. What will it look like? Well, we know it'll be a rectangle, yeah? And we know that rectangle has two dimensions, right? We're going to label them what we would normally label them. Width and length. Cool? Right? Now, what do we know about width and length right now? From the question, we know something about the width and the length. It has to equal? Not quite. Because there's two lengths and two widths that would have to equal 100. So what does one length and one width have to equal? 50. So we know L plus W equals 50, right? Everyone agrees? Yeah? And that tells us something else, doesn't it? That tells us that W equals 50 minus L, but it also tells us that L equals 50 minus W. Does it matter which one we work with? No, of course not. What else do we know about this situation? What's this guy trying to do? Oh, I should have read the question, hey? The question says that X is supposed to be width. So what should we do with these letters? Instead of W and L, what should we use? X and Y. And where should the X go? W. So sorry about that, guys. Myers didn't read the question like an idiot. So this is Y and X. So first part of this says, find the length and the area in terms of X. So we need the length. So that's right here. So what we are looking for is Y equals 50 minus X. Okay? And I also want the area using X. Well, what do we know about rectangles and area? Length times width. So X times Y is area, yes? Methinks someone should have been pursuing him. Oh, there we go.
I have to go to a trip with social studies.
What else is? X times Y, yes? Yeah. So, length times width. So this is one thing we need. The other one is width times 50 minus X has to equal my area. Is everybody cool with that? Yeah? Okay. So that's A taken care of. There is A. Now, let's do B. What does B say to do? And we should read the question first so we don't make that same... Well, I shouldn't say we. I should read the question first so I don't do what I just did and then have you all write it down wrong and say that Myers is a doofus. Find the width of the garden if the area is 525. So what do we know? We know that this is the area, the length and width. But now we know the area is what? 525, right? So how can we use that in the math we know right now? What would we do? Expand it, sure. And we'd end up with what? 50x minus x squared equals 525, correct? Does that yet look like something that we use? Does that look like standard, vertex, or factored form right now? It's almost standard, isn't it? What would make it standard? If I move the 525 over here, I'm going to have negative x, yeah? Right? Are we okay with that? How many of us like negatives? Most of us, that bothers most of us, right? So what if we moved everything to the other side? Would we be okay then? So that would give us x squared. What would happen to the 50? What? Negative 50x plus 525. Correct? Yeah? Everyone is good with that? So is this something that we're happy with? Pardon me? Yeah. Well, it shouldn't equal 0. It should equal y. Right? What? Yeah, but x is width. We wrote that at the top. It's x meters wide. So once we find x, right? Okay, now, how do we find x? We might have to do the quadratic equation. Do we? Do we need to do the quadratic equation here? What am I trying to do here right now? Trying to find the width, yes? Which means I need to solve for x, yes? So that means I need the roots, yes? So do I need to do the quadratic equation? I can find roots lots of ways, can't I? So what way do you want to use? The question was, do I need to use the quadratic equation? No, but can I? Okay, so you guys go ahead and figure that out for me. By the way, is anybody doing something other than the quadratic equation? Is anybody completing the square? Factoring? Okay. I'm just wondering. Because you have all three options available to you, don't you? I mean, I haven't looked at that. I don't know if it's factorable. But we certainly have quadratic equation and completing the square available, right? Why is this a good case for completing the square? What about this equation makes it a good one to complete the square, just in case we wanted to? X has no coefficient, and 50 is even, right? It's not going to be a crazy fraction, right? So So we could complete the square, couldn't we? Now, just out of curiosity, could I punch that into my graphing calculator right there if I wanted to? I could do that, couldn't I? And then find the zeros, which is what we're going to do in a second after we've done it algebraically. Okay? All right, so do we have an answer for me yet? Pardon me? The roots are 35 and 15? Okay, so according to Sukbal, x equals 35 or 15, right? Positive 15? Okay. Because I didn't get positive 15.
Please excuse the interruption. Could any students attending the Buddhist temple field trip please come down to the main entrance? That's students attending the Buddhist temple field trip, please come now to the main entrance. Thank you.
Because I completed the square. Are you going? Okay. Anybody? Who else is going? Okay. Make sure you watch the video. Oh, and homework tonight is going to be the review. 116, 17, 18, and 19. But you'll probably have some time on that tomorrow. Maybe I'll do one. Yeah, let's do that. 116 and 17 is homework tonight for you guys that are leaving. And then we'll do 18 and 19 tomorrow in class. Okay? Have good days. Namaste, although that's not Buddhist. I don't know what Buddhists would say. Go with peace. It's a beautiful, I assume they're going to the one in Richmond, which is gigantic. It's actually pretty cool. What I don't understand is why Buddhists have such wicked awesome temples, yet they eschew material possessions. That's what I don't get. Buddhists don't want material possessions, and yet their temples are gorgeous. I don't get it. But I don't know the religion. Well, it's not even really a religion. It's a school of thought. I don't really know. Anyway, so I got this to be negative 15 because I completed the square. But regardless, I'm going to... That's frustrating. Who else did something here? Did you all get 35 and 15, or did you get a negative? Or did I make a mistake? You got 35 and 15? Yeah? With complete the square? Because that's what I did here. Because as soon as I see complete the square, I like to do that. So here's what I did. Again, you don't need to follow along. But if I'm going to complete this square, I move this over here, yes? And I get negative 525 equals x squared minus 50x. What's half of 50? Squared? 625. So I added 625 to this side, yeah? So what do I add to this side? 625. So I end up with 100 equals x minus 25 squared, yes? Everyone cool? Then I solve. How do I get rid of the square? Square root, so I get plus or minus 10, yes? When I square root both sides, the computer's just frozen. It'll just take a sec. Equals x minus 25, yeah? Because when I square root that, that's what I get, right? Now, so x, this comes over here and it becomes 25, yeah? Oh yeah, so you still get 25. You still get 35 and 15. So I had a negative in a bad spot. So which one would we try? We're trying to maximize, yes? Can I use either one? X plus y has to equal 50, yes? Does adding those equal 50? So does it matter which one is the length and which one is the width? No. Everybody cool? Yo. Okay. So, have we done B? We know the width is 35 or 15, depending on which we want to call it, right? Okay. So let's move on to C, which we'll do in red. What does C say as a question? It says, find the maximum area, yes? Well, if it's the maximum area, then it must be the maximum of the parabola, yes? And the maximum of the parabola lives at the vertex, yes? So if I know the vertex, which has an x and a y, am I in business? So how do I find the vertex here? I can find the vertex right from here, can't I? How? What finds me the vertex? What finds me the vertex when I have standard form? Maybe I should look at page 110. What? Minus b over 2a. So what is that? What's minus b here? 50 over what? 2. What is it? 25. And that was the minus b over 2a. So that means my vertex x equals 25, yes? Right? So if my x is 25, what's my y? Because remember, x plus y has to equal 50. Y equaled 50 minus x. So what is it? Y equals 25 as well. If x equals 25 and y equals 25, then my area is x times y, so it's what? 625. That's the biggest garden I can enclose. Now, do people want to see how to take this and solve this from their graphing calculator? Do you want me to show you that? Do you wish to have a graphing calculator in front of you, or do you just want to watch? Okay, well then come and get one. Drop off what you need. All right. Was everybody able to get to here? I need you to be able to get to there because you can't use your graphing calculator until you have an equation. Can everybody do the algebra to get the equation? Awesome. So now how do I do this on my graphing calculator? I go to y and I enter it. X squared. Yeah? Okay. Minus 50x plus 525. Right? Everybody can enter, yes? Now, every calculator has a different window on it right now, correct? So right now, when I push graph, there's a chance you won't see my parabola at all, right? Graph. No parabola. Okay? Some of you will see something. Okay? If you can't see the vertex, then we're in trouble, yeah? So I got to change my window. Now, the biggest problem kids have with the graphing calculators, I don't know how to change the window. Well, let's be smart about this. We know what is the y-intercept here. 525. So my y's have to go up to at least 525, don't they? Right? So let's change our window. So our y's will encompass 525. Yeah? Everyone cool? So also, this is a real life problem, yeah? So can we have negatives? Can I have a negative length, a negative width, or so I don't need the negatives, do I? So let's change this, change our y's maybe to what? -5. We like to have a little negative showing in case we dip, yeah? What do you want to go up to? We know 525 is part of it. What should we go up to? Does it matter? No. Let's try 1,000. And our scale, if we make it 100, that'll mean there's how many ticks? 10. Now, we know our x's can go up to a maximum of 49, right? Because 49 plus 1 would be 50. Yeah? So if we make our x's -5 to 50, would we be possibly in good shape? And I made my scale 10, which will mean I'll have how many ticks across my x? 5. Let's see what happens if we graph that. Not bad. Not bad at all. Except what has happened? It's an upside down one, right? How can my maximum be on this type of parabola? What did we do to get to here? And I hid it on purpose. What should the equation have been? Why? Because it was originally -x, wasn't it? We moved it, didn't we? Does everybody remember doing that? So if you get to here and you punch it in, you need to be aware of what you did, right? Because is the calculator graphing what we did? Is it graphing what we told it to graph? But that's not what we want, is it? Because our x is supposed to be what? Negative, right? So I need to either do one of two things. Go back and re-enter it, or recognize that it's my vertex, but it's going to be positive. Yes? Picking up what I'm putting down? So if you graph it, so now we just don't have a vertex, yeah? So all I got to do is lower my y's, yes? So I'll go into my window, and I'll drop my y's to negative, drop it to -100, and graph. And now I have my parabola. Everybody cool? And then what am I looking for? I'm going to be doing some calculations, so it's second calc. And what there do I want? A value, a zero, a minimum, a maximum, or an intersect? In this case, I want a minimum because of the way we graphed it, yes? 3. Left boundary. I can see my cursor, I'm to the left. Right boundary. Come around the corner, go up the other side. Enter, guess. X is 25. Once we have x at 25, we're in business. Can everybody do it? You have to be able to do one of these methods. You either have to be able to use your graphing calculator, or you have to be able to do algebra. Do I care which one? No. Sometimes I will ask you specifically to use algebra, and sometimes I won't. But if I don't ask, does it matter? No. But you'll notice, even to do the graphing calculator, we still have to know the algebra, don't we? Everybody cool? Okay. You.
So were you saying, like, you know how we found the minimum instead of maximum? Couldn't we just, in the original equation, just put a negative in front of it and we'd still do it?
I'm actually trying to show you that, Max, but the computer is doing what it always does and not working very well for me because it needs to clean up. But yeah, remember in the original equation, it was negative x squared plus 50x. Oh, right here. So I still got to move that 525 over because on your calculator, it has to be in y equals form, right? So I would have had to move that over. So I could have entered 50x minus x squared minus 525. And order doesn't matter on your calculator. It'll work it out. You can enter anything. So if we'd entered that, this whole parabola here would be flipped over and we would be finding a maximum. Cool? But what I'm trying to say is when we made this, Cole was going to leave it negative, right? And I was okay. I wanted to get you away from that because this was easier to do the other stuff, right? Without a negative 1 there. But your calculator is smart enough to know what negatives where. It doesn't take any time to think. It doesn't accidentally do something wrong with negatives, does it? So it would have been okay. All right? I kind of manipulated you a little, Cole, there. I feel bad, but I had an end in mind that was good for everyone. So, okay? Okay. Are we all good with the first question? Okay, turn the page over. I'm going to get away from my graphing calculator for a moment. Now, what about this question makes us want to go to the graphing calculator immediately? There's a decimal, yeah? Now, could we do it with our regular calculator? Yeah, it would just be yucky, right? We're looking at a quadratic equation with decimals. Whoa. Right? So this one, I'm going to go right to the graphing calculator. Everybody cool with that? Okay. Is this in a nice form? Is it in standard form? Kinda. It's just out of order. So if I wrote it this way, h equaled negative 4.9 t squared plus 24t plus 1, could we do quadratic formula there with our old regular calculator? Could we? Yeah, because we got an A, a B, and a C, right? But that would be disgusting and barfy. So we're going to go straight to our graphing calculator. And this is already in that form of y equals, isn't it? So I can go ahead and I can put this directly into my graphing calculator as soon as it shows up. Now, what is the trick that you have to be very careful of here? What's the very first term in our equation? It's negative, right? Some of you are going to make this mistake with your graphing calculator. You're going to hit subtraction. You are going to do that if you're Russian, right? If you're Russian. Not if you're Croatian. Nothing? God, I hate first block. Russian, Croatian, Rushing. No, because my jokes are funny. You guys need to know what to do when someone tells a joke. You need to spend time in comedy clubs because you're supposed to laugh. All right, so negative, and then I just enter it, 4.9. Now, this is t. Does my calculator allow me to enter a t? No, it's going to call it x, isn't it? Because it's our variable. Squared plus 24x plus 1. Now, my graphing calculator has that weird window from the last question we did, yes? So, I can risk it and graph it, or I can change my window now. I'm going to risk it and graph it. No, yuck. You can barely see it, right? It's way down here. That's barfy, isn't it? Right? So what's the quickest way to get back to a nice regular window? Who remembers? Zoom 6. Oh, yuck. That didn't help either. Did it? So now we got to figure it out, right? Where do I need more space on this graph? Up or down? Up. So I need to change my window for more up. Is that y or x? So my y maximum is too low. How high you want to go? 50? Graph. Do we have everything we need? Yep. Now the question is the maximum height reached by the ball. So that's A. That's the height, right? Since it's a maximum, it must be a vertex, yes? How do I find it? Second, calc, and what is the choice? Maximum. Second, calc, max. Not that max, this max. And then I use my arrow keys. I'm on the left, enter. I go over the maximum, and I'm on the right, enter. Now I want it to guess, and what do I get? Do I want the x or the y value there? The y value. Why, Burke? Because we're looking for the height, not the time. And what is it? 0.387, right? 30.39 meters. Cool? Now, this is where it gets tricky. For what length of time will the ball be higher than 20 meters? Where is height measured? On the y-axis or the x-axis? On the y-axis, right? So if I go into my equations here, and I go down to a second equation, and I push y equals 20, what will that do? Exactly. Burke has done this. It will give us that line. That's 20 meters. So where is it above 20 meters? Between these 2 points, yes? So if I know this point and this point, do I know? So we're going to ask our calculator to do some calculations for us, aren't we? So we're going to go second, calc. Now what do you think we need? It's one we haven't used yet. Intersect. Look at you, Sophie. You're like Sherlock Holmes. 5. So, on the first curve, right? It says first curve. And see I'm on the parabola? So there's the first curve, yes? I'm going to hit enter. Because I want the intersect between the first thing and the second thing. Did you push second calc 5, Max?
Yeah, I want it says first curve.
Right. So now bring your cursor up near the line, just like we did before. Have you done it? And then hit enter. Now what does it say? Second curve. So get onto the line. See I'm on the line? Enter. Guess. 0.99. 0.992. So that's when it hits 20, right? So for B, it hits 20 at 0.99 seconds. Now watch what happens. I'm going to slide along. See how my cursor is sliding right along? And see how my y is staying at 20? There I am, somewhere around 3.82, right? So how do I get it perfectly? Second, calc, intersect, first curve. I want to come over to where I'm doing my business. Right there, enter. Second curve, enter, enter. 3.9. So that space of time, it's above 20. Does everybody see how it works? We have now used all 5 graphing calculator functions that we would use in pre-calc 11.
Good morning, Abby Senior. Please excuse this interruption. With those students who have volunteered to have a Japanese student buddy this morning,
Any of you?
make your way quietly down to the pit at this time. So that's all students who volunteered to have a Japanese student buddy. If you aren't sure, then you probably didn't sign up. Staff, if you want to just double check on the list that was sent out Monday, that would be great. And so if we just get you down in the pit now at this time, that would be great. Thanks.
Okay. Okay, let's go on to the last one. So, real life question, right? Real life application of quadratics. This is actually a physics question, isn't it? Any of you taking physics right now? Okay, so what do we know about this situation? Well, we know there's a typo in it. That -1 shouldn't be there, and it's kilometers per hour. So I'm just going to fix that up. What do I know about this? What is stuff that I know? Well, I got to find her uphill and downhill speed, yes? One of them, which one should X be? Should it be the uphill or the downhill? Or does it matter? Who decides? You decide. Which do you want to make X? You're going to make X the downhill speed? Okay, so that's X. So what is her uphill speed? Read the question. Her downhill speed is 35 km/h faster than her uphill speed. So if that's her downhill speed, what's her uphill speed? X plus 35? She's faster going uphill? Right. That would be X minus 35, yes? Everybody cool with that? Okay. What else do we know? We know that distance equals speed times time, correct? Right? And we know all the versions of this, right? What does speed equal? Distance over time. And what does time equal? Distance over speed. We know all that from like grade 9 science, yeah? Okay, which one of those is going to help us right now? What are we trying to find? Speed, time, or distance? We're trying to find speeds, aren't we? Right? So, we know that the whole trip took 3 hours, yes? So, uphill plus downhill equaled 3 hours, correct? Right?
Yeah.
Now, since this is in time, these must be in time, yes? So which of these do I need? D, S, or T? What am I adding here? Distance, speeds, or times to get 3 hours? Times. So I need her time uphill and her time downhill to equal 3 hours, yes? What is time? Distance divided by speed, right? Okay, so what's the distance of the trip up the hill? Read the question. 40. And what's her speed up the hill? X minus 35. Plus, what's her distance down the hill? 40. What's her speed down the hill? X. And that all has to equal 3, doesn't it? Everybody cool? Okay. Can I put that into my graphing calculator yet? What would I need to do? One thing has to move. What would have to move to and go into my graphing calculator? The 3 would have to move. So if I add this, 40 over x minus 35 plus 40 over x minus 3 equals y, could I put that into my graphing calculator and solve this problem? Is that an equation? Does my graphing calculator graph equations? So I could go straight to my graphing calculator there. How many of you feel that you could enter that in correctly? Be honest. Or would you rather see it in one nice line? Like this question. That's what you want to see, yes? But if you're good with your calculator, you could enter this. It wouldn't be a problem. Yes. Of course I'm going to. But I do want to make sure that everybody is aware that this right here can be tidied up, can't it? I'm adding fractions, yes? So what would I need? I need a common denominator, right? Now we're going to do a whole unit on this type of problem very next unit. So I'm just going to do this on my graphing calculator. Is everyone cool with that? Yeah. Okay, so how do we do this? Well, it's just like easier ones we had when we were kids. If I'm doing division on a calculator, what do I got to remember anytime I've got more than one operation? Brackets. I got to bracket that, right? Other than that, it's pretty easy, correct? So let's get our calculator up. Let's get our y's open. And let's try entering this. Come on. On. Clear. Y. Clear. Clear. All right, here we go. The first one is 40 divided by bracket x minus 35, close brackets. Everybody happy with that? Right? Plus, what's the next one? 40 divided by x, right? Then what? Minus, not negative, subtract 3. And then graph. Barftastic. What did that give me? Look at what it drew. I'm going to zoom out to show you what it drew. It drew this weird double curve thing, didn't it? Do we care about this negative part of it? I haven't taught you anything about this kind of curve. Do we care about this negative part of it? Why? Time isn't negative, and distance isn't negative, is it? So we don't even have to care about this part of the curve. Since we only care about positives, we can change our window to get rid of all of our negatives, yes? Now are we happy? What am I trying to find? What am I trying to find here? I'm trying to find x, aren't I? Well, can I? What has happened here that is getting in my way? It's graphing that weird curve, isn't it? And it doesn't look like it's making sense. So we have two things that could have gone wrong here. What are the two things that could have gone wrong? Is it possible we entered it into the calculator poorly? Is that possible? Yeah, because it's really hard to enter that in, isn't it? Right? What's the other mistake we could have made? Did we set this up right? Which one are you more confident with? Are you more confident with our setup, or are you more confident with how we entered it into the calculator? Which is it? I know which one I am more confident with for you guys. Which is it? Does this make sense? Distance over speed, time plus time equals 3. Are we okay here?
Yeah.
So we did the math right, so we must have entered it weirdly into our calculator, yeah? So let's have a look at that calculator again and see what happens. Let's look at what we entered. 40 divided by x minus 35. Okay. Plus 40 divided by x minus 3. That should work, shouldn't it? Shouldn't it work? So let's try and figure it out. We've got our graph. Let's go. What are we looking for? X, yeah? Okay, so where do I find an x value on a curve like that? We can't do it, can we? Can you guys figure out a way to do that? So, what does that mean we have to do here? Can I leave it in that form? What form do I need it in? I need a standard form, don't I? So I got to get rid of those. Right? So let's do that. How are you going to get rid, make this look like standard form? What do I got to do to clean this up? What is my common denominator? Actually, I won't do it that way. We'll do it this way. How would I get rid of this? I would multiply everything by x minus 35, wouldn't I? So if I multiply everything by x minus 35, what do I get? What happens here? Disappears, so I get 40, yes? Right? What happens here? Is that a numerator or a denominator? Numerator. So this would be 40 times x minus 35, yes? Everyone agree? Over what? X. Everyone still cool? And what would the 3 become? 3 times x minus 35. Everybody good? Have I gotten rid of all my denominators yet? What do I need to do now? Multiply everything by x. So what's 40 times x? 40x. What happens to these x's? They drop out, so it's 40 x minus 35 equals 3 x minus 35. And then I've got to multiply that guy by x now, yes? Now, are all those denominators gone? Are we happy now? Because we can tidy this up, right? 40x plus 40x minus 40 times 30 is 1200, and 40 times 5 is 200, so that's 1400, equals 3x minus 105 times x is 3x squared. Now, do we have a parabola? Now could we graph it? All we got to do is move everything to one side, yes? Everybody cool? So, what would it look like to move it to one side? I'm going to move the 3x over, get negative 3x squared. I got 80 x's here, and I'm moving over positive 105x, yes? So what's 80 and 105x? Okay, so I got 185x, and what's that? Can I put that in my graphing calculator? Can I find all the stuff I need now? Okay, I'm going to stop there because you guys got 17 minutes. You can put that in if you want, because this is the hard part, right? This was the math. This is entering. And then I want you to do pages 116 to 117 tonight. Then tomorrow in class, we'll finish review, because tomorrow's a short day. We'll finish and mark it tomorrow. Talk about what's going to be on the test. And you'll write that test sometime next week. Okay? Cool? If you want to try to enter that, go ahead. Then I'll be right back. Okay? I just got to pee.